Everyone, please help me to welcome our guest speaker, Mr. Rupich Robertson Kua. Let us all give him a round of virtual applause.
Hi guys. Yeah, virtual applause. Thank you. Um, Voice test. Can you guys hear me? Yeah, live?
Yeah,
Okay.
Rupich, yeah.
Cool. All right. I'll probably just start sharing my screen. Okay. Okay. 1 second. All right. Can you see my screen? Pretty much it's just a gray screen while you are here. Yeah, give me a thumbs up if you can. Yeah, okay. I can see someone. I think Hugh Layton's actually, yeah, thumbs upping. Yeah, cool. So I'll probably just start with why you're here, right? So let me just time myself because we only have a few hours here. Why you're here, aside from like your school forcing you to kind of like sit in for 2 hours and listening to me, I'd like you to understand that you're here to understand the power of data holds. So it's not superhero power or anything like that. Basically, to understand data more, to know what actually it can be. I mean, today or in the future. So how do I do this? So we'll go through, basically, I'll explain what's data, what's information, just to kind of like distinguish the two. I'll bring you guys back to where it was, basically the history, and then we'll pause there. We'll take some Q&A, and then we'll bring you to Web 2.0, which is the present. And I'll pretty much go through like the good and bad parts scenarios. All right, about me, I think thanks to Miss Diaz and Ms. Delantar, they've gone through basically my bio. So I currently work in NAB, which is a bank. So I'm also a father of 2 kids. So I'm old, I'm not young. Principal engineer at NAB. So what do I do? So principal engineer, pretty much like anything to do with software. So at NAB, bank, in our company, everything is online. So if you open a bank account, you transfer money, you receive money, you pay your bills, for example, everything's done online. So my role is pretty much to lead a number of teams to actually bring that feature online. So that's kind of a nutshell of what I do today. 16 years in the tech industry. This was back in Hoyo, I think. So I've done telco, retail, finance, and banking. So again, DLSU, Bachelor of Science in Computer Science, and previously I graduated in CKSC. Proud to be one. Probably not everyone knows this, but I'm used to swim with CKSC. So if there's any swimmer out there, so I probably know your coach who trains you. Also, one thing to know that I built my first HTML website when I was 12. This was back in high school. So something that not everyone knows, but it kind of tells you my profile. I'm kind of like a geek. I'm still a geek now, and I like computers. All right, so enough about me. Let me just do this full screen, actually. I think I can do full screen. You guys can see my screen, yeah? Yes, thumbs up. All right, cool. Data versus information. So what is data? What is information? I think in everyday life, sometimes we just say information, sometimes we just say data. I just want to get this out of the way. Data is raw, unprocessed, unstructured, meaningless on its own. Basically, just dot points data. So if you open your Excel, you put some data there, and that's data. On its own, you don't really understand what that is. Information is derived from data. So its process is more structured. And I'll give you an example. I believe you guys have statistic subjects. So, but data is not all about statistics, right? Just this example kind of relates to what you're learning today. So imagine you're at class 4. There's Shanna who have like 80% score of 80, and Chase is at 94, Ash is at 74, Coco is at 79. So basically, how do I derive data from information from this data? So, I can think of, say, average score is 81.75, basically a summation of those 4 and then divide by 4, and then a median score of 84. If you know statistics, pretty much getting the ceiling and the floor, and then what's in between. So that's kind of that's information out of that data. I hope that's clear. It kind of forms a pyramid where data is foundation. So dot points, imagine dot points. That's the base. Next level up is information. Sorry, information. The next level up is something else, and there's another one there. So I'll go through those question marks later on in the slides. All right, cool. I'll bring you to, I think, pre-89 or something, 1989. So you guys weren't born yet. Before the World Wide Web. So www means World Wide Web. User data back then is the primary focus of most companies. I guess why? Why? Is because we're a consumer society. So when I say consumer society, it's basically we're looping around life where we just want to consume, which means like you want better phones, faster phones, bigger cars, everything better, right? There's some bad parts there, but yeah, but that's pretty much where we live in today. So a big part of this is advertisements. I think we know that obviously because we're a consumer society. There's companies selling their products. They like to advertise, market, and then you consume or purchase their products and consume their products. Yeah, sorry, got distracted with some buzz here. All right, so advertisements back then, it comes with billboards, sometimes flyers. I think sometimes we still do that today. TV commercials especially, and goes with impressions. So impressions, just the number of commercials being played during that day. If your company wants more impressions, you pay more money. Let's take this as an example, TV networks like GMA. I know a lot of you probably will be looking at watching streaming like Netflix or YouTube. You're probably not turning on your TV to watch GMA or ABS, CBN. I'm not sure whether that's still running today, but just bear with me. So I did a bit of Google. This is the TV program today on a weekday. It'll be a different program in a weekend. So you might ask, like, well, why are you like telling me this? We all know this. Yes, we all know this. Bear with me. So this is GMA's program. I'll just go through, like, there's an early morning program. You just want to hear it. And then they're going to play a bit of commercials. 12 p.m. it's Eat Bulaga, which is a noontime show. And then 6:30, it's a news show, I think. It's 9 p.m. and there's a Korean series or whatnot. So there's TV series in there. So why am I telling you this? Back in the days, or in fact, still today, there's something called predictive viewers. So we're actually predicting a profile, or I call it persona, or actually that's my next slide, but I call it basically they predicting who's viewing, and therefore they can show what type of commercial for these certain viewers. So in this example, 5:30 a.m., let's just say that the dad is awake, is actually watching this program. The TV commercial is targeted towards the dad. Same as the mom, noontime show, probably preparing dinner or something for later. And at 6:30, everyone's home. School class is done. So everyone's watching this, and therefore commercials targeted towards everyone. At 9 p.m. it's probably the teenagers where, you guys were just sister and brother watching Korean series and whatnot. So I did mention slightly a bit around persona. So at this stage in time, this was like way back. Personas are a profile of yourself. Like in this case, it's TV viewers. It's predictive because we're not 100% sure whether it's dad who's watching at 5:30, or it could be you who's watching at 5:30, right? So in a way, advertisement back then was more of like chance, like 50% chance of targeting certain segment. And then at some point that certain segment drops to 5%, which then purchase their product. So come Web 1.0. So I think Ms. Diaz mentioned about Web 2.0, which is the part 2 of our session today. Web 1.0 is between 1989 to 2004. And I believe, based on my calculation, you guys still weren't here. 1989 to 2004. So I just need to name drop this guy called Tim Berners-Lee. So he invented World Wide Web. This was back in '89. All right, so I think he graduated from MIT. The World Wide Web is not internet, just so you know. So internet was invented way back, I think it's 81 or something, like maybe 8 years ago, 8 years ago during that year, 89. So internet is connected computers. It's basically the protocol to send data over the line, while World Wide Web is the content. So you go to www.google today, it actually shows you the content, it shows you an HTML page. If you open your application, say a Facebook application, it grabs the data from the World Wide Web. So that's www as opposed to internet. So they're two different things. All right, so back then, static websites. When I say static websites, these are websites that are read-only. There's no interactions. There's no feedback. Basically, you can't put a comment. You can't put a like. You can't do anything. You just read. All right, so it doesn't change often, hence why we call it static websites. So try to remember this word just so, because I'm going to use this in the other slides. Static means read-only, doesn't change. An example of static website early in the days is Heaven's Gate. The reason why I use this is because I think this website is still alive today. Some of the websites are already dead, but this is how it looks like. It's just static. It's purely just HTML, CSS, a bit of JavaScript, and the whole point of this is you just read. You don't interact with it. That's Web 1.0. This was, I think, built back in '96. My first website was built. I built it around '99 or 2000, so it's way earlier than my time. So early 2000. So talk about static data. Static content, static website. Early 2000, Yahoo became popular. Sorry, can you guys still hear me? Because I just saw like a loading screen. Yeah, thumbs up. Hello, can you guys still? Oh yes, okay, I got a thumbs up from hands. All right, early 2000, Yahoo, AOL, which is American Online, Google came in. So Yahoo is like a Google search engine. You're probably not using it today. You're probably using Google or something else. So these guys actually invented like user creation, like account creation. So that's where static user data came in. All right, so we're still in the data context here. So account creation back in the days, like you register for, say, a Yahoo Messenger or a Google Gmail account, something like that. They'll actually ask you for your name. In this example, let's just use Joboy Santos as the name. Birthday, 1st of Jan 2008. Location is Manila. Gender is male. So basically, this data is actually sent to whichever company you're registering to, or whichever website you're registering to, like Yahoo or Google. So let's think about how do we actually process this data. Like so Joboy Santos gave this data to Google. Let's take Google as an example. What Google can do is to derive those static user data into static user information. Remember when I said about data and info? So info is derived from data. So Google can somehow derive those data into things like teenager in school because of his birthday, and they'll be assuming that he's in school. Tropical climate, because Manila is near the equator, so therefore you're in a tropical climate country. He's Filipino with Spanish origin because Santos is of Spanish origin. So those are the things that companies can kind of derive from those data. So if you look at the pyramid again, data, there's information, and then there's knowledge. So what is knowledge? So we talk about data, we talk about information. What's knowledge now? So let's take Jawboy as an example. So I put that emoji there is because it's Jawboy's like persona. So he's a teenager in school, he's tropical climate, he lives in a tropical climate. He's a Filipino with Spanish origin. So knowledge is something to do with context or experience. It means that it's not to do with Jawboy, but it's to do with what else is out there. So Google will have a number of user accounts or user data, right? They'll study everyone's user data and try to make sense out of it. What will happen is they'll compare similar traits with other accounts. So this is knowledge, basically looking at experience, looking at the context, the surrounding area, right? And Google can say, Jawboy most likely loves Jollibee because everyone loves Jollibee. Like every other Jawboy out there loves Jollibee. Teenager in school, Filipino, loves Jollibee. Not sure who doesn't. Well, I like Jollibee. There's no Jollibee in Australia, by the way. He most likely do gaming because he's teenager in school, he's male, gaming is male dominant, therefore they can somehow say that he most likely do gaming. And we say most likely, it's not 100% do gaming, but more like 80% maybe, or 60%. All right. So what's the next one in this pyramid? It's wisdom. And this pyramid is not something that I just made up, by the way. It's called the DIKW pyramid, right? So DIKW is used across data, they call it data science, where you basically move data to info, to knowledge, to wisdom. It's a process, pretty much. So let me explain wisdom a bit more detailed here. So if you're following the colors, I'm trying to color data as blue and info as green, and then this a bit of mustard as is knowledge, and then wisdom is red. So I'll use that over the session just so we can like relate. So we have knowledge that Jawboy most likely loves Jollibee, most likely do gaming. So what is wisdom? Is it something of a higher level? No. So wisdom is something that you apply. Basically, knowing this knowledge, what are the things that you can apply with this knowledge? So it means that you know Jawboy loves Jollibee, you know Jawboy loves gaming. So ask Google, imagine I'm Google, what can I do with that? So the wisdom here is basically, if Jawboy is searching for fast food, then show Jollibee ads first. Likewise, if searching for gadget, then show gaming gadgets first. So this is just an example, a really basic example. It can be anything, right? So let me just recap the flow of data. So I said, basically, Google collects data, process info, analyze knowledge, and then apply wisdom. So let me just repeat that. Collect data. You collect lots of data points. You process the information. You analyze based off the context, based off other things, and then apply and then mix that up with the info, and then you get knowledge, which then comes with application. Basically, set some rules, set some applications that make use of the knowledge. So that's the flow of data. Now, given that example where we have wisdom over Jawboy's persona, if we relate back to the TV personas back in the days where you only have predictive personas, it's no longer predictive. It's more accurate, more precise. Basically, Jawboy is Jawboy, John is John, Rook is Rook, right? What does that mean? It means that targeted ads is more successful. It means Joeboy loves Jollibee, someone else likes McDonald's, someone else likes KFC. And by the way, just so you know, this is just an example. It's not all about food, it's about everything. So I'm making these examples so it's easier to consume. So what does this mean for the companies? Well, it's a win, right? So Jollibee wins doing that win walk. It means they're paying money for to actually present their ads. Joeboy's looking for fast food. Joeboy gets to see Jollibee, gets to go to Jollibee and get his chicken joy. All right. So I'll touch a bit on how the web works. Actually, I think I'm going too fast. How the web works. So I'm not sure whether you guys are aware of like servers, internet, sending data here and there, but in simple form, basically, if this one's your laptop or mobile device, when you go to google.com or any website, let's just say Netflix or Facebook or Twitter, as an example, you're just requesting, basically, you're sending a request over the internet. So not the World Wide Web, over the internet. Internet then sends that request to the server. Server is google.com here, which then sends back a response, basically the result of your search. So google.com here, which is the server, is pretty much just any computer. So if you have a computer at home, like a desktop computer, I think I have a slide here. Yeah. Oh, no, I don't have a slide here. But if you have a computer at home, like a desktop computer with storage, CPU, and RAMs and all that stuff, you can run a server. So if you're using a computer today, or even using a mobile phone or iPad, that's actually a computer. You can run a server on that. And someone else can do a www.roop.com and then access your computer. Well, access in a way that it's like a server. All right, I hope that actually is clear and easy to understand. But we'll wait for questions later. So a server, again, just like a computer, has a CPU processor. So this is process binary data and stuff. So binary data is it. So in this context, it's just 0 and 1. There's storage, which is your hard drive. Nowadays, I think if you're technical enough, if you built your own computer, there's M2 hard drives nowadays. But still, back in the days, they're just this form like this. And RAMs, random access memory. Right. Okay, so I'll give you an experience where I've set up a server back during my startup days with a telco. I think this was back in Hoyo. Like I said, you can technically have your home server, like build your server, install your code in your server, and then host that, and then someone else can go and hit your server. You'll then provide the HTML and CSS and JavaScript back to them, and then you'll have that, like a website on your own. But companies don't do that, mainly because if you run it at home, you run your service at home. Imagine Google's running their service at home, and there's blackout, or we call it brownout in the Philippines. That means your server is down. It means, it's just down. You're constrained with that environment. So there's something called data centers. So data centers is pretty much like a warehouse or a building with AC aircon to actually make sure that there's controlled environment. The servers are cold, the internet is fast, connection's fast, and someone, say like myself, if I want to deploy or host my website, I'll pay data centers. I'll go to the data center, plug in my server, just like my computer there, and then let my computer sit there. So this was back in the days. One example was when, some drawbacks with this data center was when we wanted to upgrade storage, for example, let's say our server is full of data now, and it only has, say, 4 gigabytes of hard drive. We'll need to come to the data center, take out the server, bring in a new server with like 1 terabyte of storage, and then restart the server. So these are all manual back in the days. So it means a company goes to a data center, do that. There's downtime. Sometimes you go to Google, you'll see downtime, but not. I think nowadays that doesn't happen. It's a good. I'm just telling you this to understand how do we actually deploy servers back in the days? Because this is not how we do it today. All right, Web 2.0. This is around 2004 to present, right? So just for context, around 2003, just before Web 2.0, Google AdSense was introduced. This is basically the Google Ads you see today. So that's Web 1.0, which I kind of just discussed earlier, the Joeboy persona. So what is Web 2.0? So Web 1.0, just to recap, is static content, which means you can't do anything. Web 2.0 is user-generated contents for users. It means that you got a website, you come in as a user, you generate content, and other users then read your content. So that's Web 2.0. So basically things like, I think it's YouTube, where you upload your video, someone watches your video, and vice versa. TikTok, everyone knows about TikTok. Give me a like if you guys know TikTok, or actually give me a like if you don't know TikTok. Oh, Aiden said he doesn't know TikTok. So yeah, good for you. Yeah, okay. It's Aiden Ned. I'm not too sure how to read your Chinese name, but I'm Chinese, by the way. It's just that, yeah, I'm too far out of touch. Facebook. So Facebook, obviously you post, someone reads, your friends read your posts. They like or dislike. Instagram, Twitter. This one's not so popular, the LinkedIn. So I use LinkedIn a lot because it's mainly used for professionals. This is where you put your professional profile. Reddit. So back in the days, Reddit is quite popular. I'm not sure whether you guys know Reddit. Can you give me a like if any one of you knows Reddit? Okay, Aiden knows Reddit. Aiden seems to be quite technical here, huh? Yeah, maybe I'll ask a question later. Okay, cool. So Web 2.0. So Web 1.0, I said, so back in the days, I said like user data is the primary focus of most companies. And guess what? It still is, right? So it's becoming more digital in a way, and with the help of tech companies. So nothing has changed pretty much from back in '89 until today. Everything's about, in a way, surrounded by advertisement, consumer society. And now with the help of tech companies, whether that's good or bad, we don't know. We'll see. Let's take Facebook as an example. Social media, Facebook as an example. Give me a like if you don't know Facebook. Okay. Someone doesn't know Facebook. Ants Jarin doesn't know Facebook. Okay, so Ants, give me another like if you don't know Instagram. Okay, Ants knows Instagram, but John doesn't know Instagram. Mike doesn't know Instagram. Okay, that's good. But in a way, social media, at least you know Instagram, at least you know Facebook, but they're all pretty much the same. And by the way, Instagram is owned by Facebook as well as WhatsApp, just so you know. So Facebook as an example. So Facebook is a platform. Just imagine, this is an analogy. Imagine it's a fish pond. So Facebook is a fish pond, okay? So a fish pond will have fishes like orange fish, the dolphin. Actually, no, let's change this. The dolphin actually doesn't exist in the fish pond. Let's just say it's a sea, okay? So Facebook is a sea. Has dolphins, blue fishes, crabs, blowfish, shark, lobster, shellfish, and turtle and octopus. Yeah. So there's fishes. Facebook is the owner of the sea. They own the fishes. They try to make the fishes swim around the sea. And there's fishermen. So not just one, but there's like not just four, but basically there's multiple fishermen. So guess what? I mean, I think everyone here is probably smart enough to understand where I'm going. The analogy here is the fishes are the personas, are the people, basically us, the users, and the fishermen are the companies who sold you ads, right? So Facebook, as an owner of the sea, this platform, their job is to make you happy, basically make those fishes swim around, social around, and make you happy and generate data. So that's pretty much the analogy of how I see social media today. And that's in a nutshell. So let's take Joeboy as an example. Again, this is Joeboy who likes geology, okay? So we know that Joeboy is Joeboy Santos, lives in Manila, and I think 1st of Jan 2008, that's his birthday, and gender is male. So Facebook can keep asking you about static user data. Like one example could be like, what's your interest like? What's the books that you read? So you go into Facebook, update your about me, and it means that more static user data for Facebook means what? It means more information. So just follow the color, okay? So green is information, and more information means more knowledge, right? And knowledge comes from the user base Facebook has when they're comparing. And then more knowledge means more wisdom, so basically more application for knowledge for Facebook. All right, so this is where I introduce real-time data. So we talked about static user data, where it doesn't change much as well. So Joeboy Santos is always going to be Joeboy Santos. What is real-time data? So when I said there's a limit for Facebook to actually get your user data, your static user data, and their job is to make us happy socializing within this sea, just so that the companies can somehow target ads to you. What real-time data is something of the next level for social media company. And you know what? Why? Because the personas, the details that the persona of the Joeboy actually evolves, right? So as a basic human being, we are dynamic. Say you are a 14, 15-year-old student, you're going to change in a year time in a fast-paced way because you're still young, you're teenagers, you're going to change, you're going to evolve, you'll be changing your interests. You might like doing gaming today, but tomorrow is doing data science because after this session, you love data science or something, right? So it also comes with experience. So people influence you, you change, you get into a moment where you feel like you're tortured, you kind of sway away from that, you change. So that's real-time data. And basically, yeah, actually where's my story there? So let's take Joeboy as an example. This is Joeboy's static user data. He likes fried chicken, Chicken Joy, we know that. Jollibee has spaghetti as well as fries. Question is, how do we turn this static user data into moving, right? So moving points. So infinitely moving, I just keep collecting Joeboy's data. And obviously by tracking Joeboy's activities, I think everyone knows this already. It's probably out there online and says social media is actually tracking how every step of your daily activities. And most of you might be thinking, okay, I don't use Facebook or I don't use Instagram. I just use this or TikTok or I don't post in Facebook, for example. Posting in Facebook is actually just the tip of the iceberg. Like if you don't post, it doesn't matter. Like they still track you in a way. But the question is how, right? So Let's go through Facebook features. The like. So when you see something, people like your post, basically one way of Facebook knowing your activities is you liking a content. And around that content, there's a category, right? So someone posts a content, that content is actually categorized as, for example, fruit or Jollibee or fast food or something like that. If you like that content, they know that you like this content. And number of likes, number of activities, that then grow over time. So back in the days, it was just like, right? This was around 2000, I think 2010 to 15, it was just like, and then they actually move on to upgrade the like button to emotions. So what does this mean again? It means like is just one data point for them. Now there's 6 more data points to tell you that, oh, I like it, I love it, this is so funny, this is shocking, this is sad, and this is angry. Angry means dislike, right? So it kind of helped Facebook know more about you, your feelings, your interests, basically learning how you grow. And there's behaviors. I would just drop this scrolling behavior, for example. So as an engineer, as an online web engineer, I can tell you that everything you see on screen, we know what you're doing. I can put code to actually know where you're scrolling, where you stop, where you pause on a certain feed. It means you pause in like suddenly you see like a shiny car or a pretty young woman. Oh, I know that you paused there 5 seconds. I know you like this. Or look up a friend. So I know where you click. I know what you search. I know what to suggest. When you do a search there, there's a suggestion. I know exactly everything you do in my website. So that is true story. So it's not really something magical because everything is code. Hashtags. So hashtags is something on the other side of the table where when you post something with a hashtag, you're kind of helping Facebook categorize that certain post. So if someone likes it, it kind of adds to their data point, if that makes sense. Hence why there's hashtags. So I think I didn't mention this before, but you know that Facebook is free. It's like a freemium model where anything is free. They have to kind of like get money somewhere else, which means the company. And all these features that they're building, which is free, is pretty much to add that social activity networking. Marketplace. So you might be asking, oh, like you go to Facebook. I don't think Instagram has marketplace today, but or TikTok. Facebook has a marketplace where you can sell your goods, whether it's brand new or secondhand. You might be asking, like, why are you doing this, Facebook? Well, again, it's data points. So when you're looking for something in the marketplace, Facebook knows that you're looking for brand new shoes or sneakers, for example. So that's additional data point for them. Groups. Groups, again, is something to group us together, where let's say you're a religious group, you like shoes, you like Nike, or you like basketball, for example. Basically, another data point for Facebook. Stories. This is something interesting. So stories wasn't there back in the days, but now it's there to generate, again, social activities, because youngsters like yourself are kind of like they're bored with scrolling down the news feeds rather than stories. It's just automatically scrolls for you, so you just sit back and relax. So in a way to generate activities. Now I've put this Ray-Ban stories over here, this Sunny or this sunglass over here, and there's a camera over here. So this is real. It's actually on sale. Ray-Ban is partnering with Facebook, where you can just tap on your sunglasses, create stories for you, and then it sends basically uploads that story to Facebook. Why is Facebook doing this? Again, it's free, right? So everything is free. So the more devices that actually can churn out more contents, the more activities, the more activities the fishes can kind of like go to, right? We're the fish again in the sea. So everything Facebook do, anything social media do is about content to generate activity. Again, activity and then data points. Next off is in a relationship. So give me a like if any one of you is in a relationship today. Anyone? Let me just zoom my list. Anyone in a relationship today? Okay, these guys are playing itself. That's good. That's good, right? Teachers are here, so you don't, you don't spill. You can send me a DM if you are. Yeah. Okay. So I'll tell you why in a relationship matters. And you have to ask yourself, like, why is Facebook interested with me in a relationship with my wife? Well, it's simple. Again, it goes back to data collection, right? So if let's just imagine your girlfriend or your boyfriend, you guys are in your in a month's time, it's your anniversary. Facebook will know that you're you're gonna have your anniversary in a month time, and Facebook can know that your girlfriend is looking at this piece of, say, watch, for example, and in a way, Facebook can send you advertisements around watches as the guy, and then you'll kind of tend to kind of like purchase that watch, and then that's what you kind of give your girlfriend, and your girlfriend will be shocked. Oh, how did you know this? Like, you're perfect. You're the perfect man for me, right? So that happens in real life, and that's for sure. Now, parents, siblings, cousin, that's the same thing. Mother's Day, Father's Day, siblings. So it's not just about anniversary, but more of that connected, the connection of those fishes. For example, if you're in a group, those fishes are in a, let's just say, a school of fishes, then it's easier to kind of like understand who's actually influencing you, what's happening in your daily lives. It's the extended way to track your activities. All right, single sign-on. So anyone knows about this single sign-on? Basically, you see continue with Facebook, you go to TikTok, log in with your Facebook. Give me a like if you know this. Not sure whether everyone's noticed, but no one's liking. So imagine you go to TikTok, or imagine you go to an app. Basically, you don't need to create another account for that certain app. You just log in with Facebook. Again, why? So Facebook doesn't give this for free. The reason why you can log in with Facebook with that integration point is basically, imagine this is the sea, right? You got the sea. The more connection Facebook has with other applications like TikTok, it actually, widens their sea, becomes an ocean. Basically, they're now more connected application, and goes back to data. All right, let's go back to Jawboy. Real-time data of Jawboy. Imagine at some point in time, he now doesn't like fried chicken and spaghetti. So he doesn't like Jollibee anymore. He grew out of it. So he wakes up around 1 a.m. So he's online. Actually, no, it doesn't probably mean that he wakes up at 1 a.m., but he's online 1 a.m. He now is into fitness. He's conscious because he just wants to change his lifestyle. He wants to be healthy. So he likes broccoli now, and he super likes strawberry. He goes offline 8 a.m., travels to Hawaii, fell in love, in a relationship with someone, and that someone loves sushi and broccoli. So this is just a simplified version of the activities, all right? So after a while, your persona changes. Jawboy's persona changes, become a beardy guy. Like basically, he grew up. He now likes strawberry, sushi, and broccoli, right? So in a way, your persona, which is a specific, I would say a static persona back then, is now an evolving persona, day by day, second by second. I'm not sure how Facebook do it on whether they actually generate data on a daily basis or on a per minute basis, but this is pretty much the simplified version. So Jawboy gets old. He now just likes egg, tea, and sip of wine because like old people likes to do that nowadays. Once you get even older, you just want to rest, sleep, and travel the world. So your persona evolves with you, pretty much. So you might be asking, like, where's the science in data? Like, we talk about data science, talk about Facebook, social media here with collection of data. So where's the science, right? So let me recap. So collect data, process information, analyze knowledge, apply wisdom, DIKW. So the science here is basically the how to collect data and how to process info, how to analyze knowledge, and how to apply wisdom. Now, unfortunately, I cannot tell you how Facebook process info, knowledge, and wisdom. It's not public, but basically it's a science that the science is around the how to. So what I can tell is how to collect data. Obviously, you've seen the examples. Part of the data science is this whole cycle. Like, how do I collect data? By what means? What form? What devices? How do I then have this algorithm to process to information and analyze the knowledge and apply wisdom? So 4 points there, 4 how-tos. And finally, how do I scale these? So remember when I said back in the days, Web 1.0, I have to go to the data center, upgrade the system when it's full, the storage is full, and then the system goes down and I have to restart it. And actually not restart it, basically bring in the new server and then restart it. How do I scale this? Like, if Facebook is tracking activities, and that's infinite, by the way. So imagine they have 1 terabyte of storage. How can they just keep going like infinitely? That's a big question. That's magic, right? Without going down. All right, someone's on speaker, I think.
Sorry.
All right, so how do they scale? Like, how do they infinitely collect data, process info, analyze knowledge, apply wisdom? So apart from the obvious, like nowadays computers are super fast. Like, there's GPU, there's CPU, there's M2 storage. That's not important, and those details are not important. But all I'm saying is, nowadays the amount of processing power we have is equivalent to maybe equivalent to like maybe an hour processing power we had back in the days. This was like 10 or 20 years ago. So hardware is going faster and faster, and that kind of helps the company to process data faster, right, in real time. But the real reason why they can scale up so fast are these cloud services. I'm not sure if one of you or some of you have heard about this, but Amazon is not just an e-commerce website. So they're not just selling books or products. Google is not just a search engine. Microsoft is not just your Windows. All of them have cloud services. What is cloud services? So cloud services are pretty much a service where you log into Amazon and then you create servers with Amazon, which means if I go back to my data center here, you no longer go to data center. You just tell Amazon online that you want servers, right? In a programmatic way, all right? So it's not in manual way. Amazon actually have their data centers somewhere in their land or in their warehouse. We don't know. There's a couple of data warehouses that Amazon, Google, and Microsoft owns, but that's no longer relevant to us. We just need to know that we want a server. Amazon does it for us. Google does it for us. Microsoft does it for us. You just have to pick who you want to go with and have the money or fund to do it. So what does this mean? Okay. So it means that, let's put this into perspective, going back to the IKW diagram. So there's data, right? Again, info, knowledge, and wisdom. So every part of this layer For simplicity's sake, let's just say it needs a server to process. So in this case, there's a collector server to collect data. There's a processor server to process info, an analyzer, and the rule server to apply these rules. So all of these are servers. Like imagine there's 4 servers here, right? And these gray circles are real-time data coming in. So your data, basically, your everyday data when you use TikTok and Facebook. So this data that comes to the collector server is they're unpredictable because the number of data varies. It means tomorrow there might be 10 million data because people are more active. Today might be just 5 million, right? So companies nowadays, they don't handle the data centers. They go to Amazon, like I said, programmatically have a feature called scaling, auto scaling. What does this mean? Auto scaling means you can, once data actually ramps up, when there's more demand, the collector server now becomes 6 times collector server. So kind of like divide and conquer. There's 6 of the server now. It's actually collecting data much faster in parallel in code. Okay, so the servers actually scales up based on your code. Same as a processor, it scales up the analyzer, scales up the rule server as well. Now, obviously, the 6653 here is just an example. It can be, as far as I'm aware of, Facebook's most likely running 1,000, if not 100,000 servers. And imagine doing that manually. That's not going to scale. But going through those cloud services, it's infinite, pretty much infinite, to the point where the max limit of the servers probably, if let's say Amazon only has 1 million server and you took out all the million server, which is almost impossible. Same as scaling down, because when we say auto scaling, it said scales up, it also scales down. So companies nowadays, they actually scale down their server when there's not much activity, which means you save money, right? And that's the full power of technology today, and why we're seeing more and more of these companies, these social media companies, streaming companies, or YouTube like that, where it seems like there's infinite resources, and they can process, or they can collect and process data instantly. Right. So next one is the bad parts. 55 minutes now. I'm just time checking myself. Is there anything in the chat? Let me just check. Yes, the bad parts. All right. Data breach. So as the name suggests, data breach is someone hacking or your system and your system breaking, and then they'll be able to grab your data, or data leaking, where a company actually leaks data out, which means their code is not secure enough. Now, one example which happened to me 2 months ago, this was Optus. Optus is an Australian telco company. This is exactly, they're exactly like Globe or Smart Telecom, or I think Sun in the Philippines. So the thing about Optus or telco in general in Australia is when you register a SIM card, you actually give your driver's license to identify yourself. So there's a regulation where if someone is going to be provided with a SIM card, like a number, they need to verify you for security purposes. So basically, if you scam someone else, they know that it's you. I know that in the Philippines, they don't do that. Sometimes they just hand over your SIM card and you can do whatever you want, right? But in Australia, it's slightly different. Now, but that's not my point. My point is my driver's license is attached to that SIM card, and Optus actually has an archive of everyone's static user data, okay? When I say static, it's not real time because they don't track us anyway. It's just static. So driver's license have my birthday, my address. And when this happened, this was 2 months ago, everyone's like freaking out in Australia because they know where I live. They know how old I am. And not just that, but the birthday is actually quite important here. Birthday is when you actually call someone to identify yourself. You have to tell your birthday just to prove that it's actually you. So having that that information kind of promotes people who can pretend that you and that well, who can pretend that you're me. That makes sense. So that's kind of significant. So in a way, imagine if it's not just static user data. Imagine Facebook at one point leaks our information, your real-time data, your real-time user data. That's even more scarier, like in the future, right? So it means that whoever has access to your data knows your entire life. Well, assuming you're very active in these social media apps. Next one is exploits user data. So what I meant was, I think, user data exploitation. So I put there the fried chicken, let's say Joe Boy, right? So because we're the fishes in this open sea and companies are the fishermen's, I think just so everyone's aware, advertisement is some kind of programming. So when I say programming is the more you see that certain ad, the more you get programmed. It doesn't matter whether you actually read them or not. What matters is the impression, basically how many times it actually shows up in your screen. So one example could be like, if let's say you're not even interested with Jollibee, or yeah, actually not Jollibee. Let's go with, you're not even interested with Palmolive shampoo, which is well, Palmolive, I think here is a green, it uses a green plastic container, so the branding is green. The more green shampoo you see, which is Palmolive, and at some point in time when you go to the grocery, you need to look for a shampoo, you tend to buy the green shampoo because of that programming. So when I say about user data exploitation is, that's just one example, is companies with with good amount of funds, the more money you have as a company, the more money you pour into advertisement, can manipulate user, not just buying shampoo, but you can manipulate user into something else, basically the way they think, right? So that could happen if it's not taken care of, or if the companies who owns this open sea doesn't regulate that. Data is forever. So Joe Boy, when he's growing up to the age of, I don't know, retirement, everything is forever. His data, his activities is forever. So you've used Facebook today. You probably will be telling me, hey, Sir Rup, I might just delete my Facebook today or turn it off. Well, that's not going to really help, to be honest. So you turn off. So as an engineer, I'm going to share you this is true story. As an engineer working in this space, data is not deleted. So just to be clear, data is not deleted, never deleted. So we do not delete data, regardless whether it's user data or something else. It's an archive. So when we code stuff, when a data is there, someone else tells us that we want to delete it, we actually mark it as archive, not deleted. It means it lives there. It's still referencing back to you. It's for reference. It's for auditing at some point. But for social media giants, obviously, is to gain wisdom around you, right? So you delete your data, you open your Facebook, it's gone. Yes, it's gone on your screen, but it's actually in their database. Why is that important for them, or for companies like I won't say like us, but basically the tech companies? Because for social media companies, data is gold. So the DAKW pyramid, the how-to part, the data science part, can actually be replayed. Imagine the data science that we have in place. The how-to part is kind of flawed today, for example. And in 10 years' time, you had this idea, or Facebook has this idea of, let's change the algorithm. Let's rerun this processing against all of our archive and understand more about Joe Boy. Right? So that's the power, kind of the power of data there, where it can go back in time and understand you fully in 5 years' time. Hence why we don't delete data. So the good parts. So when there's good, there's always when there's bad, there's always good. Just-in-time content. So just-in-time is, or we call it JIT or JIT, is kind of to do with engineering, where it's just-in-time scaling, for example. But in this context, it's just-in-time content. So what I meant here is, imagine you're looking for something. Imagine you're looking for your for a medicine, for example, and it's hard to find, right? And if data can help you pinpoint where that medicine is, imagine you went to can think of a location. So let's say you went to a shopping center in the Philippines, and somehow that pharmacy has the medicine that you're looking for, and it notifies you there that, hey, this is the medicine you're looking for. Go to this and get it, right? So that's really useful. That's something powerful, and it's really good. It saves us a lot of time. It might save a life next time. And that's how I think the good part of data is. So knowing you is okay, but maybe limited knowledge, but not everything, like, you know, everything about you. But those things actually make sense. That's just one example again. Okay, moving on, second part. Before we actually move on to the second point here is I just want to go through, not really go through, but basically give you an awareness of Maslow's hierarchy of needs. So as a human being, we have needs of food, which is at the very end, physiological food. Safety is, I think, around shelter, and I think money as well as health. There's love, belonging, esteem, and, you know, self-actualization. So esteem is basically your confidence. So social media always boosts your confidence. So it's up here somewhere. Not a lot of companies funds the lower end here, which is food, safety, and health. So a good part of data, I would say, is agri-tech. So in my bio, I've worked with Observant. So they're actually an agricultural tech. So they're basically tools where, so data is not just user data. So it can be anything, right? So in this particular example, it's agricultural data. It means that you can measure the moisture content of your soil, the pH level of your water, the weather, which is around you, whether it's going to rain tomorrow or it's going to be super hot tomorrow. All of these things. So I don't think we've applied a lot of those data science, DIKW pyramid and processing stuff with agri-tech. And I think if we do, agriculture, which is our food, can probably improve I would say the quality of the crops, and basically stop wastage in a way at some point, right? And I think I've seen also there's some companies who actually recycle water, clean water, and then bring it back to the plant. So this is something that I started to see, but it's not really well known because of money mostly goes to advertisements. Again, because of consumer society. Second part is health tech. Sorry, third point is health tech. So imagine your user data today. So, you know, like you go to your doctor, we call it GP, general practitioner here. You go to your pediatrician or your doctor. And if you switch from this doctor to that doctor, you then again will tell you, I'm allergic to peanuts, I'm allergic to lactose or something like that. And I have a disease before, yada, yada. I'm diabetic, I'm blah, blah, blah. You have to go it over and over again. You got to present your data again. And then depending on how good your doctor is, they'll probably ask you for more. So with health tech, it's pretty much using your user data across a central system, or when you're born, and then as you grow, as you probably found out that you have, like, say, asthma or whatnot, everything is recorded. So when you move from doctor to doctor, everything is recorded. Like, you don't have to repeat yourself in a way. So why is this really good? I think it's really good because imagine imagine you're in an accident, right? You're coma. You can't speak or anything. If a doctor knows everything about you, then the diagnosis, the treatment is way better than not knowing you. So that's really powerful in a way that, like we save lives, not just save life, basically improve life. You extend your life. And that's the whole point of humanity. We want to extend your life, right? And that's health tech. And I don't see, I mean, I'm starting to see this in Australia where everything's somehow connected, where there's a bit of user database around myself, but not enough. I guess the pandemic probably will tell you, the COVID pandemic will tell you, I mean, we lost a few people that we know. Like imagine if you know that you have this certain disease and merging that combining that with COVID will mean that that will be critical for you beforehand. Imagine the number of lives you save there. But we're not there yet. So that's a good part. Okay, time checking again. I think this is almost my last slide. I don't know you, but I actually do. What do I mean by this? This is pretty much the future that I see. This is what I see. It's not, it's just me, my opinion. It means that you go to, say, a barista or Starbucks, right? Nowadays, if you go like 8 a.m., order your cappuccino, if you know the barista will probably not ask for your order and then just give you a cappuccino and you pay $3 or whatever, how much peso in the Philippines. So imagine not just hospitality or restaurants or ordering something. You walk in, as long as you got your persona or your profile, you tap on it, you get your coffee. You don't have to repeat yourself again. So I started to see this in McDonald's kiosks. So I think you guys have kiosks in your McDonald's right now, but I don't think there's user data involved yet. Imagine you tap on to that kiosk and, well, let's just go with Jollibee Jollibee, and then it instantly knows that your favorite is Chicken Joy with double gravy and double rice, right? So that's convenience. Future can be most likely be, like I said, the health tech, where the doctor doesn't know you, but it knows your user data, your real-time or static user data. Traveling, so passport, you go to an immigration officer, you're gonna go take a picture and then talk to them. I think that's inconvenient. If everything is there in the system, you might as well just walk in. You've seen most likely in Singapore where I think there's a Cheers grocery where you just walk in, or Amazon grocery where you just walk in with your phone, you get what you need, you walk out. You don't even need to pay. So they automatically deduct based on your credit card details. School, education, and jobs. So I'm in between with this where it's kind of scary as well as 50-50. What could happen in the future is if the school actually collects your data, basically your scores, and then you don't have to go to, I think if you're going to a certain uni, so let's say De La Salle University, you have to go for the entrance exam. Imagine you don't have to do that. It's just based off your user data, and then you can just go into La Salle, for example. And at some point, De La Salle University will also add on to those data that you have during your university days. And then when you apply for a job, employer like myself, before I do the interview, I can pretty much know your profile. So it's kind of good and bad. I'm not so sure whether that's good or bad, but I think that will be the future. So, right. So I guess, yeah, thank you. Thank you for a couple of people here. I'd like to say my parents, because not because I want to thank my parent here in this broad forum, but mainly my parents back in the days when I was like 11, 12 years old. This was during the boom of World Wide Web. They actually bought me a computer with a modem. So back in the days, there's dial-up modem. I think without that, my I probably won't be convinced that or basically I won't be persuaded to take on a computer science course. So it's for awareness. So I hope this talk actually gives you awareness. So kind of more like an aha moment that kind of like brings you to a certain topic that you want to go to in the future. Maybe STEM, for example. STEM, by the way, I think science, technology, and then EM. So STEM here in Australia is pretty big. So primary school already have STEM, by the way. So my son at I think year 4 will have STEM. My nephew is at year 6 does programming in Python. So yeah, technology is going to be a big part of our evolution. And I strongly believe that, I mean, you're young. I strongly believe that your generation will be post-fix with tech. When I say post-fix, it's like help tech, something tech, something tech. Educators, some of my previous teachers over here, they obviously they helped me become me. Educators of today, I'd like to thank you, and for the students who are here, I think teachers are actually one of the primary educator that you guys have to look up to. They're the mentors, and just imagine since you guys are the future, imagine the responsibility teachers have. So thank them, and I thank you, teachers. And to you guys, students. So thank you for sitting for, so I just timed myself. It's 1 hour, 15 minutes. Okay, so it's not 2 hours. It's 1 hour, 15 minutes. I hope this actually helps you.